Hi everyone, and welcome back to Physics with Mr. Simons, right, where we simplify your physics and get you exam ready. Today's lesson again, we're looking at acids and bases, and we're looking specifically at past exam question from the Eastern Cape, the Prelim 2022 exam paper, right? So let's look at the question. So question 7, they say the equations below show the reactions occurring in hydrochloric acid and ethanoic acid solution, right? Both acids have a concentration of 1 moles per decimeter cubed and are kept at temperatures of 25 degrees Celsius. So HCl, hydrochloric acid, reacted with water to form chlorine and hydronomium ions, H3O+. And there the constant of that acid was 1,3 times 10 to the power 6. Then we have the ethanoic acid reacts with water. Ethanoic acid donates a hydrogen and forms hydronomium ion, but its concentration of this acid 1,8 times 10 to the negative 5. So this is lower than that. Define an acid according to the Lowry-Bronsted theorem. Write down one conjugate acid base pair in the reaction 1. So for that reaction there, which solution 1 or 2 will have the lowest pH value? Explain your answer. We're going to use the constants of acids to explain. So, pardon. 7.2, we have 10 cubic centimeters of 1 mole decimeter cube sodium hydroxide solution. It's diluted with water until its pH is 13. Calculate the number of moles of sodium hydroxide in the 10 cubic centimeters of the initial solution, 3 marks. Calculate the volume of the diluted solution in decimeter cubed for 4 marks. Alright, or 5 marks. Then they say all of the diluted sodium hydroxide solution is poured into a burette. During a titration, 15 cubic centimeters of oxalic acid of concentration 0,09 moles per decimeter cubed is exactly neutralized by a certain volume of the diluted sodium hydroxide solution. Balance equation for the reaction, sodium hydroxide, right, reacts to form the products, right? So calculate the volume of the diluted sodium hydroxide that's left in the burette after sodium hydroxide reacted with oxalic acid, right? So without further ado, let's look at the solution. But you see what happens if I try to fit the whole question on one page? It looks too busy. But yeah, I'll break it down and answer them piece by piece. So the equation below shows the reactions occurring in hydrochloric acid and ethanoic acid solutions. Both acids have a concentration of 1 mole and are kept at temperatures. Now, according to Lowry-Bronsted, acid is a proton donor, right? It donates a hydrogen ion. So acid is a proton donor, 2 marks. Write down one conjugate acid base pair in the reaction 1, right? So there the hydrochloric acid and chlorine would form a conjugate acid base pair. So hydrochloric acid is the acid. This here would be the base because it donates the hydrogen to form that, but this would accept the hydrogen to form that. Therefore they are conjugate acid base pair. Or hydronomium and water, H2O, donates the hydrogen or accepts the hydrogen, and there to donate the hydrogen. So base to acid, right? Conjugate acid base pair. So note when the acid HCl donates a proton, a conjugate base Cl minus is formed. Acid and a conjugate base that forms are called a conjugate acid base pair. 7.1.3, which solution 1 or 2 will have the lower pH value? Explain your answer. In this case, solution 1. HCl is a stronger acid than, can I eat a blank like it? Ethanoic acid. Alright. HCl has a higher constant for acid than ethanoic acid. So HCl will produce a higher concentration of hydronomium ions. Right, so in short, 1, 2, 3 marks, right? So that's the basic theory. Next question. 10 cubic centimeters of 1 mole decimeter cube sodium hydroxide solution is diluted with water until its pH is 13. calculate the number of moles sodium hydroxide in 10 cubic centimeters of initial volume. So we have concentration, which is 1 mole. We have volume, which is 10 cubic centimeters divided by 1000. So give me 0,001 times 1 becomes 0,01 moles. So you should remember moles equal concentration times volume, 1 mark. Another mark there for correct substitution of 1 and 10. And third mark for the answer. 7.2.2, they say calculate the volume of the diluted solution in decimeter cubed. So they've given us pH is 13. Right? Equation for pH, high potency of hydrogen equal negative log H3O plus concentration. Right? pH is 13. We naturally assume you know that the original logs has a base of 10. Alright? So from there, you can take concentration over H3O plus, and that becomes 10 to the power negative 13. Right? So constant of water equal my concentration of OH minus times the concentration of H3O plus. Concentration of hydronium ions times the concentration of hydroxide ions. So the constant of water is 1 times 10 to the negative 14 equal OH minus, and there H3O plus we got 10 minus 13. Alright. Now remember, we want the volume of the diluted solution, which is sodium hydroxide, so therefore I need to know the concentration of OH minus. Right, so from there 10 to the negative 14 divided by 10 to the negative 13 would basically give me 0,1 or 10 to the negative 1, which is 0,1 moles per decimeter cubed. Right, my concentration of OH minus equal my concentration of sodium hydroxide. Remember, sodium is much just a spectator ion. So therefore they both equal 0,1. Right, but they want volume. So we have concentration. So concentration equal moles over volume. Therefore volume equal moles divided by concentration. My moles was 0,01, which I found there. My concentration is 0,1, which I found there. And if I divide the two, it gives me 0,1 decimeter cubed. So 1 mark for correct substitution, 1 therefore 0,1 decimeter cubed. But the key point is you need to be able to work there. Work from log to exponent and from exponent to log. Right, so I hope you follow and understand. Let's go look at the next question. Now they say all the diluted sodium hydroxide solution is poured into the burette during a titration. 15 cubic centimeters of oxalic acid of concentration 0,09 moles per decimeter cubed is exactly keyword neutralized by a certain volume of the diluted sodium hydroxide solution. So when we neutralize something, we reach a pH of 7. Balance equation, sodium hydroxide reacting with oxalic acid form my two products. Right, so calculate the volume of the diluted sodium hydroxide that's left in the burette after that titration. So concentration of the acid given there was 0,09. The volume of the acid is 15 cubic centimeters divided by 1000 if you want to change to decimeter cubed. Concentration of my base here is 0,1 mole sodium hydroxide. Alright, so for neutralization, concentration acid times volume of acid divided by concentration base times volume of base equal my moles of acid divided by my moles of my base. Alright, so there substitute in 0,09 times 15, the bottom 0,1 times the volume of the base. There in the ratio, my acid there is 1, my base is 2, so 1 over 2. Alright, so from there, multiply 2 across, 1 comes to the bottom and VB comes over. So VB equals 0,09 times 15 times 2 over 0,1 times 1, which gives me 27 cubic centimeters. To convert to decimeters, 27 divided by 1000 equals 0,027 decimeter cubed. Right, so I started with 0,1 mole of base. Right, that was for my volume. Right, as you can see there, concentration, the volume there, I add that, so 0,1 minus that gives me 0,07 decimeter cubed remaining. So 1 for correct formula, 1 for correct substitution there in the first part, correct substitution second part, 1 mark for subtracting with 0,1 decimeter cubed, which were given in the beginning, subtracting, and answer. So hope you follow, hope you understand. Wish you nothing but the best. Bye. God bless.